Begin with the warm-up. All the vocabulary words on this page are extremely important, so if there's anything you don't understand, make sure you research them. Pause the video now. Let me know if you have any questions about any of these. And here's our learning target for the day. I'm sure you're familiar with the term parallel lines, but we're going to dig into it a little bit deeper mathematically in this lesson. Parallel lines are two lines that never intersect. That means they'll never cross each other. There will never be a point where they meet. We have a symbol for parallel lines because we don't like to write it out all the time, and that is two bars that are actually parallel to each other. It looks like the number 11. It is not, however, but that's the symbol we use for parallel lines. And here in this picture you can see that I have two parallel lines. But there's something very important about the equations of these two lines. So I would like you to solve each for y. That is putting them in y equals mx plus b form, because we need to analyze the slopes of them. So pause the video and solve each of them for y and tell me what you get. Here I've matched the color with the line to show you the equations of the blue line and the red line. It's important to look at the slopes of parallel lines because something very special always happens, which is kind of intuitive if you really think about it. And the thing to notice is that the slopes are the same. So looking at our blue line, you can see that our slope is -3/2. And our red line, also -3/2. You need to have your equations in slope-intercept form to be able to tell that the slopes are the same. So if it comes to you in standard form, you're going to have to convert. Let's try this activity if you have a graphing calculator. On your graphing calculator, can you do y equals 2x plus 3? You could also play around with it on GeoGebra.com. Graph that line, and then try to graph another line that is parallel to it. You know what's required. Write the equation of the line that you made up that is parallel to the first line. If you need to borrow a graphing calculator, just ask. This is an important step in order to fundamentally see what is happening between parallel lines. Now we'll do it on paper. In example 1, we are asked to find the slope of the parallel line. So looking at number 1, what do you already know about the slope of the line that's going to be parallel to it? Hopefully you said you know the slope is going to be 3/4. For number 2, what is the slope of the parallel line going to look like? Well, since the slope of example 2 is 2, the slope of its parallel line will also be 2. And you could put little marks down here, those parallel marks, if you wanted to communicate with someone that you're talking about the parallel slope. Example 3, you write it down first. Hopefully you said it was -3. In example 2, you will be asked if the lines are parallel to each other. Looking at the two lines, this one is already in slope-intercept form. This one is standard form, so we can't tell what the slope is until we convert it into slope-intercept form. So to do that, I would subtract 4x from both sides. Divide by 2. And remember, you have two fractions going on here. My first fraction is the negative 4x over 2, and I can reduce that to negative 2x. And the second fraction going on is the 6 divided by 2, which is 3. So now our job is to look at the slopes of the two lines. Are they parallel? Yes or no? Because the slopes are the same, they are parallel. Let's do example 2 together. Again, my first equation is in slope-intercept form, so I already know that slope is 4. The question is, what is the slope of my second line? Again, we'll convert it into slope-intercept form. And I'm putting the x term first, but you certainly don't have to. You just always need to know that the slope is the number before the x value, or the x variable. Now this slope became negative 4/3, and this slope was 4. So are they parallel? No. You try these couple of practice problems. For number 3, they're both going to need to be converted into slope-intercept form. And number 4, you'll have to convert the second equation. I think I'm missing an x here. Go ahead and try these two problems. Pause the video now. Take a look at this work and the answers. Number 3, they are parallel because their slopes are both negative 2. And number 4, they want to be parallel, but apparently they're not because the signs are different. Your signs also have to match. So because this sign here is a negative 1/2 and this sign here is a positive 1/2, they are not parallel. Now here's the grand finale. We can write equations for lines that are parallel to ones that we are given. They will always give you an equation for a line, and then they're going to tell you that your parallel lines equation that you're going to write needs to pass through a certain point. So looking at example 1, you are given the equation y equals 5/2 x minus 4, and that's an equation for a line. If we graphed it, it would look like this. Now I am being asked to write an equation for a line that is parallel to the red one, and at the same time goes to the point negative 2, 3. Well, how do we do that? Our first job should be to figure out what the slope of the parallel line will be. And you know that the slopes need to be the same, so it would be 5/2. Now, we're going to use point slope form. Remember, that's y minus y1 equals m times the quantity x minus x1. I have a point, and I have a slope, and I will substitute them into point slope form to write an equation of the blue line. That's what it will look like. You certainly can leave it in point slope form because I didn't give directions that said turn it back into slope-intercept form. All we were asked to do was write an equation of the line that's parallel to the red one and goes through the point negative 2, 3. If you wanted to see what it looked like graphed, you can see the slope from the point that I've plotted is going to be 5/2. So I'm going to go up 1, 2, 3, 4, 5, and over 1, 2. And then you can draw your line through there. And I'll move mine over in a sec. And you can see they're parallel. Let's try it again with number 2. I will get rid of these, and you don't need to graph these. I just did it for an example so you could see what was going on. Alright, so we are given the equation y equals negative 2/3. I'm just going to leave the blue one here, I guess. Y equals negative 2/3 x plus 12, and it goes through the point 5, negative 3. Your first job is to understand what your slope is going to be of your parallel line. And as long as you've been paying attention to this video, you know your slope is going to be a negative 2/3. So we're going to use this slope and this point and write an equation in point slope form. I would like you to give it a try just to practice with point slope form. Go ahead and write the equation. If you have any questions about what's going on with the signs there or why the 3 and the 5 are going where they are, you need to ask, because this is not going away and it's a really important skill. So hopefully you've learned something in this video. Our next video will be on perpendicular lines.